So in next week's lab, you'll all be performing a titration between calcium and ethylene diamine tetraacetic acid. So in this video, I'll sort of talk about the background chemistry of that, as well as describe the sort of technique of the titration. So safety glasses always first, and here in this beaker that I've prepared, this Erlenmeyer flask that I've prepared, I have the calcium sample that we'll be analyzing, a buffer that is made of ammonia and ammonium chloride to bring the pH of the solution to about 10, and some Erlenmeyer black tea indicator. That Erlenmeyer black tea is binding to some of the calcium ions that are in solution. Once that happens, the complex formed appears the sort of reddish wine color. Right. Into the burette is the standard EDTA solution that I've made up, and I'm just opening the bottom of the burette to sort of start my titration. So initially, we don't see a ton of color change in this titration. Adjusting the camera here for a second, it's mostly staying this sort of wine red color. The reason for that is earlier I said some of the indicator has bound, some of the calcium has bound to the indicator, but not all of it, right? So first the EDTA is reacting with the free calcium. Now I'm getting kind of close to the endpoint. You can see some sort of blues starting to show up. What's happening here is the free floating calciums that are in solution, the EDTA has started to react with all of those, and so now it's starting to take away calciums that are bound to the indicator. The indicator, once it's free floating in solution, appears blue in color. So where you see the EDTA starting to drop, I start seeing blue pools kind of forming, right? So now that I've seen those blue sort of pools start to form where the EDTA is, I'm going to slow the titration down. And if you cut back to the beginning of this video, the color that we're at now is a lot less red than when we started. It's kind of starting to get purpley hues, right? Which should make sense. If you have unbound indicator that's blue and bound to calcium indicator, it should look red. So red and blue mixed together make purple, right? And as I'm getting closer and closer to the endpoint, all right, so now that last drop snapped it from kind of a purple to a blue, right? So I think this is my endpoint in this titration. I still have a drop on the tip of my burette. That's actually been dispensed, so I should rinse that into the bottom. So I'm doing that here. So they're tapping it to the side of the glass, rinsing it in. Right. Your burette readings, in order for them to be accurate, you have to get anything you've dispensed off the tip into the bottom. Right. So I think I'm close. So that was a little hand gesture here. So I'm going to record this volume that I'm at. Right. So I'm going to do that, and then what I'm going to shortly follow that up with is add a tiny bit more, like a fraction of a drop or maybe one more drop, right? So I'm going to let out a part of a drop here, and then I'm going to close it. Oh, actually, I let out a full drop, but what I'm looking for is where that drop landed. If where that drop lands, I see a different shade of blue, then I'm not quite at my endpoint. If where it lands, I don't see a significant color change, then I'm done, right? And the reason I'm doing this is it's hard to see red to purple to even more bluish purple to blue, right? So what I did was I just let the bottle or the Erlenmeyer flask sort of sit for a second, calm the water, and then add a drop and see. Right, so I'm just refilling the burette here with more of the standardized or the standard EDTA solution that you'll make up in lab, right? So ethylene diamine, sort of tetraacetic acid, has a lot of protonated acetic acid groups, and if you look in your lab experiment, there's a picture of it, sort of before. You put it in a buffered solution and after, right? So the buffered solution, the main sort of purpose of it is to deprotonate the EDTA such that it can bind readily and predictably to the calcium ions that are in solution. It also deprotonates the Erlenmeyer black tea indicator so that it can also bind readily and predictably to calcium in solution, right? So I've kept you'll notice in the left of the video, I've kept the previous trial as a reference, right? This is actually just a very good practice to do when you're doing titrations, just to have a comparison from the previous trial. Hey, did you get the same color at the end point? And it's kind of just a good reference to have. So this one I'm doing a lot faster than the previous one. Notice I'm swirling constantly. I'm starting to see blue kind of start to show up. So instead of a wide open stream, I'm going to go to quick drops. So maybe a drop every second or so, but I'm still swirling with one hand. And I have my hand on the stopcock to the valve on the other one. So that way, if I see a sudden color change, one hand's up ready to shut it off, and the other hand's there swirling and ready to go. So I'm just holding my phone here up to give you a better, the lighting's kind of rough, but we're still kind of in the reddish, sort of maroon color. All right, so during that whole time, I was adding drops, which are still going, about one a second here. Right? And I'm trying to get a better representation of what this sort of color change looks like. So we're still kind of maroon. I'm starting to get a little bit away from the red end and starting to tip our way into purple. So I'm probably pretty close to the end point of the video right here. Right? So there comes the purple. It comes quite drastically. And then I think I'm really close here, so I'm slowing way down. I'm doing a drop, swirling it, letting it see what color it is, adding another drop, swirling it and letting it see. So I think I'm close-ish here. There's definitely still purple in it quite a bit. If you look at the flask on the left compared to this flask, right, they're distinctly different colors, right? So I'm not there yet, but I'm close. Right, so that's what I'm trying to show here. So sort of the key here to I guess any titration is to develop a technique where you can get consistent results. And how I do that is by sort of going fast until you start to see a color change show up, and then slowing down. And then once you start seeing even a more drastic color change, slowing down way further and doing like I'm really close to the end point here. So what I'm going to do is just add a drop or a part of a drop, right? So sort of letting a drop come out, I'm starting to swirl. So the drops are coming, I don't know what, one every 2-3 seconds here, right? And I think this is almost it, right? So I'm tapping off the tip. You notice that, like, as I'm pulling the Erlenmeyer flask away, I'm tapping the tip of the burette to it to always make sure that if I've dispensed any of my titrant, in this case EDTA, that it's in the flask, right? So I pulled up the first one to sort of compare in color. I'm writing my endpoint volume down here. Right. Sweet. So in this video, there's a couple of more titrations to go. Oh, sorry, I apparently didn't think I was done here. So what I'm doing is I'm putting the Erlenmeyer flask back and I'm letting it settle. Right. So I'm just waiting until the water is just almost perfectly still. And then I'm going to add a tiny bit more and see where it lands. And I'm looking to see, where did that drop land? Is there a difference in color? If there isn't one, then I'm done, which I am. Right. So again, always tapping off the tip of the burette. The reason to do that before starting the next trial is I would have still had a little bit of a drop from the previous trial left over, right? So that's going to bias my results in the next one if I don't take care of it. So there's two more titrations in this video. You can sort of watch if you want to kind of keep getting a better idea of the technique. But it's me repeating the same process. So I'll sort of narrate those, but if you think you've largely got it at this point, you can stop watching the video. So I'm just getting my initial Buret reading here. You'll notice I kind of tapped the Buret with my hand a little bit. I had some air bubbles or something. You always want to make sure there's no sort of air bubbles obscuring the top of your meniscus, so that you can get a good reading off of the Buret. I guess I didn't point this out earlier in the video, but look at how I'm always positioning the Burette tip inside of the Erlenmeyer flask, right? I do that for a very specific reason, so I don't spill, right? It's about a ½ an inch into the Erlenmeyer flask. That way, if I'm swirling, I don't ever accidentally swirl and just miss and shoot some on the side of the flask and then have to start the titration over because I will have dispensed some that didn't end up into my sort of reaction solution down below. So I started with a wide open stream. Now I'm going to quick drops. I'm pointing out, one every ½ a second or so. Once I see that purple color start to creep in, I'm going to go to probably a drop every second or a drop every 2 seconds. So there's one other thing. So again, pay attention to this. I have both hands involved. One is swirling, one is on the Burette, ready to close it at a moment's notice. Right? You don't want to do one hand for everything. You always want to have one hand on the Burette so that you can close it immediately when you need to. Right? You don't want to have to, oh crap, that's my endpoint, and reach. You'll have overshot it at that point. Right, so I'm almost there, but not quite. Again, I'm pulling up a previous trial to compare to. So I'm going to add, I think, another drop here or less. So I'm letting out part of a drop. This is a very sort of good technique. So I let out a bit of one, closed the Burette, tapped it to the side, taken my squirt bottle, and rinsed it in. And you can do this for most titrations. The amount of water that you add doesn't matter in the vast majority of titrations that you do. Sometimes it will, but it's sort of more advanced stuff where you need to know like the total volume that you've added. But yeah, for this, the little bit of excess water doesn't matter. So I'm doing this, tap it to the side, rinse it in, give it a swirl, compare to my previous one, and I do this 3 or 4 more times until I reach the end point. Right? And I guess I should point out, from these trials, I got extremely close repetitive volumes, right? Like all of my trials have very close Burette volumes for every single one of them. And like this just comes with practice, right? But watch this video, sort of pay attention to the things that I'm doing. I've been doing titrations for like 15 years now, so I make it look easy, and I know what I'm doing, but I've been doing them for so long. I've been trained of how to do them so that the results are reproducible, I guess. I guess the main ones are always make sure that your Burette tip is below the top of your Erlenmeyer flask, so you don't accidentally just dispense on the outside. And then always make sure that anything that has been dispensed ends up in the Erlenmeyer flask down below. All right, so always tap off the tip of the Burette so that it ends up in the bottom into the Erlenmeyer flask. So just getting my Burette reading for the final trial here. It's hard to see in this video because it's cropped, but when I'm reading the Burette values, I don't know if you've been noticing, I'm leaning forward, right? So what I'm doing is trying to read the meniscus at as level of a line as possible, and I try to get my eye as close as possible in order to do that, right? So because of the video, I'm leaning forward to do this. If I were doing it on my lab bench and I didn't care about recording this video, I would have scooted the Burette backwards towards me so that it was almost on the edge of the counter, so I could stare at it straight on easier, right? So just other things to be aware of. I think this last titration is the quickest because, I mean, this is the fourth one I'm doing, but and this whole video is only like 17 minutes, and I did 4 titrations. So you guys should be able to do these relatively quick. Don't rush them though, right? I mean, the lab will take you more than 20 minutes because I prepped everything ahead of time. I already had the EDTA solution made. I had all of these flasks made up where I had pipetted the calcium sample in, I'd put in my buffer, and I'd put in the drops of indicator, right? So, and sort of largely the point of this video is just to show you guys the color changes in the titration and how to sort of get the most reproducible results that you can. So I'm grabbing a previous one to compare here. I'm not actually there yet, so gonna add a tiny bit more. I think I'm there. So I'm recording my Buret reading, and that's it. So again, maybe I'm not 100% sure I'm there, so I'm letting the water set. I've already recorded my volume, so I'm adding another. This didn't change the color, so my previous recording must have been the endpoint, right? So that was me. The point up was like, oh, the previous one was where I was at. Just in case, I'm going to write this new one off to the side. But I'm going to use the previous number in my calculations, right? So, yeah, that's it. Thanks for watching. You know, talk to your instructors with questions that you have. But yeah, good luck in the lab.